Hello everyone, welcome to OdinSchool. Today in this class, we are going to learn about the most important aspect in statistics. One is correlation, another one is regression. We are going to see both of them are contextually similar, but we are going to see what is the difference and what is the use case and when to use what and how to use a particular type of analysis. That is what we are going to see in this class. Let me quickly ask the first question. Why should someone learn Excel? Talking about statistics is simply nothing but one of a vastly used or vastly consumed subject in both professional as well as personal life. Any decisions that we take in real time as well as in a business completely relies on numerical operation. Say for an example, I wanted to buy a shoe. I need to know what is the size I need to buy a shoe for. I cannot buy a shoe that cannot be under my size or above my size. So even for the slightest of the decisions that we have to take, the smallest of the decisions that we will take in both personal as well as in professional life needs numbers, and these numbers are powered, and the numbers can be understood as useful information by the help of statistics. So irrespective of your domain and the role that you are going to be a part of, statistics is very important for both personal as well as professional life. Let me quickly introduce about OdinSchool and introduce about myself as well. OdinSchool is a technology upskilling platform. They help us continuously acquire new skills. Their motto is to stay skilled and stay ahead. About me, I'm Gautam Kumar Jayachandran. I have 6+ years of experience as a senior data scientist. I've worked in several domains like retail recruitment. I currently work with finance. I use a lot of technologies in my real time, starting from Excel, SQL, Python, Tableau, machine learning, and analytics. With that said, let's see what is today's agenda. First, we will understand what is Pearson's correlation coefficient. Then we will understand what is regression analysis, what it can do, and we will see two types of regression analysis: simple linear regression and multiple linear regression or multiple regression. We will see how to perform all these operations with a lot of examples. Let's get started with Pearson's correlation coefficient. Pearson's correlation coefficient is simply nothing but a correlation matrix used to identify the relationship between two numerical variables. That is the idea. When we have categorical variables, if I wanted to figure out whether categorical variable A is related to categorical variable B, I will not be able to decide without knowing the relationship between them, and the relationship has to be quantifiable in nature. I would say 60% of variable A is correlated to variable B. That way I can understand how much of an impact variable B will have to go through by changing something in variable A. That's the idea of correlation. Theoretically, Pearson's correlation coefficient is a measure of strength of the association between two numerical variables. First step in studying relationship between two continuous variables is to draw a scatter plot of the variables to check the linearity and understand the relationship. Now, rather than seeing it theoretically, let's say it practically. Let me take a data set. We have a Google Play Store dataset. I'm going to just keep two numerical columns, um, ratings and reviews. Let's put this into a new dataset. Perfect. Now in this case, reviews and ratings. What is a rating? This is purely a dataset coming from Google Play Store. So when we have products, the ratings will be given by the users, and basis the number of reviews, the ratings will differ. Now we clearly know that rating is something which is given by the reviewers, and ratings is generated through reviews. So there are good chances that review and rating are pretty much correlated with each other. Now in this case, looks like there is a lot of nulls in the data set. Let me simply remove them. Okay, apply a filter. I'll simply remove the nulls out of it. We don't want any nulls to be part of the data set. That way it will confuse a lot. So I'm just removing the nulls in the data set. I'll remove the filter now. Perfect. So we have data for 9,300 incidents. Now, all this reflect to different products. Now, if I wanted to know whether there is any relationship between reviews or not, reviews and ratings, I need to quantify it. If I want to quantify it, I need to know a metric. So since both of them are numerical in nature, what I'll simply do is I'll take the help of Pearson's correlation coefficient and generate the relationship. But before performing the operation, let me explain what is Pearson's correlation coefficient and we will figure it out how does it actually work. Now in the center, I'm trying to plot two axes, x and y axis. Okay. Now in this case, let me increase the size of this a little. It's too big. Okay. What is this axis? This is a axis with both plus and plus. Both my x-axis and y-axis is in positive only because I have 0 1 2 3 here, 0 1 2 3 here, so it is positive positive. This is the direction of positive positive. Then in this case, if I talk about this, my x-axis is positive but my y-axis is negative in this case. Then in this case, my both x-axis as well as y-axis both are negative comma negative. Then in this case, my y-axis is positive but my x-axis is negative. Now why do I do all this why do I do this logic? The understanding of uh, the understanding of Pearson's correlation is that when the signs are similar, when I say signs are similar, characteristics are similar. According to Pearson, if both the data points share similar characteristics, if a data point A increases, if data point B also increases, then it says positive correlation. This particular zone is actually positive correlation. Let me simply change this to this and then say positive correlation. So basically, if there is such addition in my x variable, my y variable also gets added with some value, something, it increases. The idea is if if variable x increases, variable y also, this is the idea of positive correlation. Talking about negative correlation, when there is an increase in when there is a decrease, maybe I'll just use a different color. Yeah, when there is a decrease in variable x, my variable y also decreases. Or in the increase of my x, y will get decreased. That's the idea behind negative correlation. So in this case, what we are seeing is negative correlation, where the characteristics of both the variables are decreasing in nature. So Pearson's correlation says that if the characteristics of two variables, two numerical variables that we are trying to plot is increasing in both, the increasing, if x increases, if y increases, then it becomes positive correlation. For negative correlation, there are two use cases. Either when I actually when I decrease my x, my y also decreases, or when I increase my x, my y will get decreased. That is negative correlation. Zero means no correlation. If you see this direction, if you see this direction, it means no correlation. The contextual idea is when there is difference in characteristics. If the variable a and variable b are not having similar features and similar characteristics, then there is no correlation between them. So there are three types of correlation that can be understood from Pearson's correlation. Let me write it here. Pearson's correlation coefficient, it is actually denoted by capital R. Okay. Now it is calculated with the help of Correl function, but let me explain the range. -1, 0 and 1. -1 means the data is negatively correlated. The numbers are negatively correlated. It is always in percentage. If it is minus something also, we will consider it as negative percentage. 0 means no correlation. This is the range of Pearson's correlation, and this means positively correlated. Let it be there as it is. So this is the range. So whatever the value that we generate out of these two columns, we will compare it with the range and understand how well they are correlated. Let's calculate it with the help of Correl function. My first array. Do I have nulls in my arrays as well? Looks like I had. Let me, however, see the data. Looks like there's a character in it. Or it can be 3,000, 30,000, 3 lakh, 30 lakh, basically 3 million. Okay, now let's calculate this and see the function. The function is Correl. I'll ask the machine to supply the first range and the second range. Wanted to see how well ratings are derived through reviews. There's only 6% of relationship, but this seems to be wrong because of the way that I assume that because of the way the data is distributed, there might be text in it. So what I'll simply do is I'll keep only the first 50 observations and remove everything. Now if I simply see the relationship between rating and reviews, it says 21 percentage only they are correlated. Even though we believe that reviews are the main reasons for ratings, it says ratings are not so very gratefully correlated with review. This seems to be little odd to believe, but the data is designed, or the data is present in this way. Now, to give you a better example, what I'll do is I'll take a data set and put it in Python and show you how the heat map in Python helps us understand the relationship between all the numerical variables that are present inside the data set. So whenever we are performing this in a larger scale, not necessary that you have to do it one column, or sorry, one column against another column at a time. What we can rather do is we can build everything together at once and show the relationship between variables. Let me take a data set where we have good numbers. I have superstore data set super. So I'll take this data set, simply copy the name of this data set. Yeah, perfect. So let me read this file and then show it to you. How does it actually look like in real time when we perform a heat map plotting the correlation. So I'll import the basic packages that I want. Okay, now let me read this file. So let's see how many columns and rows are there. It's an unique code error. So there will be a huge data. 51,000 observations are there, rows and 24 columns are there. If I wanted to see what are the columns that are there, these many columns are there. I wanted to know how many numerical columns are there in it. So I'll use the info function to retrieve me the data types of each and every column. There is one integer, there is another float. We have float, integer, float. So it looks like we do have really good number of numerical variables. So what I'll simply do is I'll simply ask the machine to perform a heat map using Cbond. I'll simply say SNS dot heat map. I'll ask the machine to show me the values as well. Let's see what it is going to generate for me. Okay, made a mistake. It should be the correlation that we need to generate. So in the data set, take all the numerical values and plot a heat map for me with the help of Cbond. It will give me each and every possible correlationship with all the numerical values. Row id is a numerical value, postal code is a numerical value, sales is a numerical value. So in this case what we can ignore is we can ignore sales and sorry row id and postal code does not actually give us any information towards business. They are categorical variables only, but since they are present in numbers, basically a correlation tries to plot it. What we need to understand is this piece. In this piece we will be able to understand how well the data is correlated between each other. If I wanted to know how well sales is correlated with quantity, so quantity and sales are only 31 percentage correlated, which is a shocker to me, because if I sell more quantities then only I will have more sales, right? But in this case they are only 30 percentage correlated. If you see what is the best thing towards sales is shipping cost. So shipping cost has a huge role to play in terms of sales. If I'm shipping the product at a least cost, then I will have more sales. If I'm shipping the product at a very higher cost, then the sales is going to be very less. And if I see the other correlationship, this actually has the better relationship in positive, and I'm not finding anything else which is having good correlationship. Every other variable has very poor relationship only. Sales and profit has 48 percentage relationship, which again makes sense because my profit is purely decided by the number of sales that is happening. So the relationship between numerical values can be generated or understood with the help of correlationship, which is Pearson's correlation coefficient. Let's see what do we have in this case. Regression analysis. The next topic is regression analysis. When I say regression analysis, it is also as similar as your correlation metrics only. In correlation metric, we will see how well the variables are correlated, numerical variables are correlated within it. Variance and regression analysis, what we will do is we will try to understand what is the relationship between my independent variable and the target variable. I'll explain what is my independent variable and what is my target variable. So the idea is very simple. If I have two numbers, purely regression works on numbers only, just like correlationship. So when I have two numerical columns, now what is the relationship between them? Correlationship talks about what is the percentage of change will happen in variable B if variable A is impacted. How each and every variable can bend towards each other when there is a change with some one of them. That is the idea of correlationship. Various regression analysis talks about the relationship between two variables. It can be it not necessary that it has to be correlated, right? But it can have some type of relationship. It can have a linear relationship, it can have a logistic relationship, it can have some other relationship as well. Regression analysis tries to identify the linear relationship between two variables, whether they are directly connected with each other or not. So well, there are multiple types of regression analysis. their core, they all examine the influence of one or more independent variables on the dependent variable. Now I've taken this. Now let's take a sales data. That way we will have more better understanding towards information. We close this. Let's take the same superstore data set and take sales information, because that way we can relate to what happened. Okay, it's all loading. Fine. So linear relationship regression analysis is all about how well the relationship is established between two numerical variables, and what is the how much it will tend, how much change in variable A will tend in variable B, and can we rely on this to create a pattern out of it. So regression analysis is a predictive analytics mechanism where we will be predicting what will be the relationship in terms of a particular pattern. So in this case, I don't want all this information of data. I just want these numerical values: sales, quantity. Let me take only these two for first. Perfect. Okay, we have this. How many line items we have? We have 51,000 observations. I think it is too much for us to consume in the first place. So what I'll simply do is I'll take maybe the first 100. Okay, in the data set we have sales and quantity information. Now my what is my understanding here? Sales is driven by quantities, right? This is my general understanding. This is the actual fact also, because sales cannot generate numbers without the help of quantity. So in this case, just yeah, in this case let me just maximize this. Perfect. So what is my independent variable and what is my target variable? Independent variables are values, target are dependent. Independent variables are always denoted by x, target variables are always denoted by y. Now the idea is, what is independent variable? In this case, sales is dependent on quantity. If I have less quantity, my sales will directly decrease, right? So that it is directly connected or directly dependent on quantity, whereas quantity is not dependent on sales in this case. So the idea is, anything that we use, independent variable is simply nothing but the dimension or the column that is used to predict the target variable. So basically, we have quantities. Let's see what are the unique quantities that we have in this data set. 1, 2, 3, 4. See here, only 12 quantities are sold. Now the question is, what will be my sales if I have 100 products sold, 100 quantities, but we do not have any actual value for this. So what we will simply do is, we will ask the machine to retrieve us input. Looks like there are a lot of duplicates in terms of quantity. Um, Okay, that's fine, I think. So let's keep it as it is. So in that case, what if I sell 100 products? What will be my sales? This is something that I need to predict. But before predicting it, let us plot the data and understand how the data is distributed. Scatter plot is the best chart to understand the relationship between two continuous variables. It looks like the data is very much scattered here. There is no pattern followed. If I sell one quantities, I will generate this much of sales, multiple sales. If I sell two quantities, this much sales for three quantities, and so on. The data doesn't seem to look very stagnant in nature, or very there is no pattern that is present in the data set. The idea of regression analysis takes the help of simple linear regression. Okay, I take the help of simple linear regression and plots a straight line as a pattern. A linear is basically straight line, so it simply plots a straight line as pattern and considers that as the pattern. So why do we need to create a pattern, you can ask me. The idea is, say for an example, you go to your office from your house every day. You have to commute like 10 kilometers. Now all of a sudden you found a shortcut which will take you 7 kilometers, but there will be traffic in it, right? There are multiple ways in which you can go to your office, but if you can identify what is the best line of it, what is the best route which has minimal distance, which has minimal traffic, which saves a lot of time for you, then you are going to follow that route only, right? So linear regression also does take the same concept. It wants to identify the line of best fit and follow the same pattern for the rest of the data set. That is the idea behind regression analysis. Now what I'll simply do is I'll plot this and plot a regression analysis directly in the chart, and then I'll show you how to calculate it to perform linear regression plus trend line. In trend line, by default it chooses linear only. See here, this is what we have here. So it says follow this straight line as pattern. What if the value, if I sell 100 products, I'll tell you how to calculate it, and then we will calculate it for different quantities that are not there in the data set. Let us complete the theory portion, come back here. We will see the regression analysis in both Excel and Python. Aggregate functions, yes. So what is the line of best fit with minimal errors? So just as I spoke about the identifying the best route for commuting to your office with minimal traffic and minimal things, the idea behind simple linear regression is to identify the line of best fit which will have minimal errors between each other. Then talking about simple linear regression, it is theoretically a statistical method that allows us to summarize and study relationship between two continuous variables. One dependent, denoted as x, is regarded as the predictor, explanatory or independent variable. So basically using x variable only we will be predicting y. Okay, let's see them one by one with examples. First, let me create a data set and explain you everything step by step. You don't have to know the step by steps, but knowing step by step operations in machine learning algorithms like simple linear regression always helps us. I'm going to create a data set first, and then I'm going to explain you how to achieve this output. Now we are going to perform simple linear regression. Say for an example, basis experience, we are going to predict the salary. We'll keep 11 10 character 10 line items, a small data set for our understanding. Now let me randomly generate experience starting from 1 year to 11 years of experience. I just don't want duplicates, so we will have good instances. 1 2 3 4 5 6. Looks like we have good data set. Perfect. So salary also I'm going to supply as starting from 10,000 to 95,000 can be given. Looks very weird, but yeah, let's keep this randomly generated data set. Okay, let's plot this data set also. Look at this. There is no pattern in giving salary to it. Look at this. A person with 12. What is this? This is actually X salary. X-axis, Y-axis is my salary. X-axis is my experience. For someone with 11 years of experience, he will get 10,000 paid, which doesn't seem to be the right number. Even though the data is randomly generated, there is just to prove it is randomly generated and kept. I'm just showing you the information here. There is no pattern in it. Ideally, as the experience increases, the salary should also increase, but that is not the case in our real time in this data set that we created. In order to predict the salary, we are going to use experience as a input variable. So in this case, what is my experience? Experience is simply my x variable, salary is your y variable. Okay, to calculate simple linear regression, first we need to know what is simple linear regression. Y is equal to mx plus c. The line of the equation of straight line is basically linear regression. Now in this case, m is simply nothing but the slope, c is simply nothing but the intercept. Okay, let me take a line. Now assume the data is distributed like this. The data is having a lot of variance from the mean without doubt. Now in this case, what is slope? Slope is simply nothing but the direction in which the data is distributed in both x and y axis. It is the direction or angle in which the data is distributed. To plot it, I might choose a different color. Say for an example, this is the line. Maybe I'll put it in a more better place. Assume this is a straight line that we are going to generate as a part of regression analysis. Now what is slope? Is slope is the direction in which the data is distributed in both the directions. So say for an example, my slope can be anywhere. Okay, my slope can be anywhere. This is exactly what your slope is. We will be able to calculate this with the help of certain functions. I'll show you how to calculate slope. I'm sorry about that. Excuse me. So this is my slope. Talking about intercept, intercept is simply nothing but the point of intersection. Now let me take this. The point of intersection is actually called a slope. When I say point of intersection, it is simply nothing but the point where A meets B. This is intercept. Okay. How to calculate intercept and slope? So if I know what is my intercept and slope, I will be able to generate yeah, y is equal to mx plus c, because we know y. What is y? Our target variable. What is x? Our independent variable. We have both the variables present in the data set. So we will be able to, if only we calculate both slope and intercept, then it will be easy for us to predict what will be the salary for someone with an experience of 15 years, which is not in the data set. Okay, let me show you. Now we do not have anyone with an experience of 15 years. What suppose, the question is, what suppose if some candidates comes with an experience of 15 years, what will be his salary, his or her salary? This is what we are going to predict with the help of simple linear regression. We need to know what is slope, what is intercept. We know the theoretical understanding it, but how to calculate this mathematically? It is simply calculated by x minus x bar the whole square minus y minus y bar the whole square. It is actually plus, I believe. So the x minus x bar into y minus y bar, my denominator is this, sorry, my bad. So it is basically x minus x bar into y minus y bar divided by, so it is divided by x minus x bar the whole square. x bar the whole square. This is the formula to calculate slope. So the logic is, how will I calculate x minus x bar and y minus y bar and achieve the slope out of it? So in this case, what I'm going to do is, first let's calculate the x bar. X bar and y bar are simply nothing but the mean value of my independent variable and target variable. X is simply nothing but my independent variable. Y is simply nothing but my target variable. Okay, so this is what we have. Now in this case, let's manually calculate each and every step, and I will also show you how to calculate the values without manual steps, and we will also see the same in Python. Okay, the first thing is calculating x bar. Now I'll calculate the mean value separately. Okay, the mean value for this is average of experience. Average experience is 6 years. Let's calculate the average salary, 54.8. What we need to do now is calculate x minus x bar first. Is x minus x bar. Then we will calculate y minus y bar also. Then we'll multiply x minus x bar with y minus y bar. Then we'll calculate x minus x bar the whole square. Once we calculate this, we'll calculate the average of this. This is my average of my numerator, and this is the average of my denominator. Once we have this, it'll be easy for us to calculate the slope by dividing my numerator with denominator. In this case, it is all error because we do not have any values. Let's supply the values one by one. X minus x bar, x minus, this is my x minus x bar, y minus y bar, which is salary minus average salary. Now multiply x minus x bar with y minus y bar and calculate this number. This is the average that we have for my numerator. My denominator is x minus x bar the whole square. So see here, the slope value is minus 1.71818. Now we have values like this. So we have a value called y is equal to minus 1.71818 into x plus c. But the problem is we still do not know c. How can we calculate c? So c can be calculated as c is equal to y minus mx. What is c then? So to calculate intercept, I'll simply say okay, the intercept is y minus mx, and the average of y is what I'm going to consider here, minus m into x. What is my m value? This is my m value into x. It gives me 65 point something. Now, as I told you, the same thing can be calculated with the help of functions also. I have a function called the line estimate, which will calculate the slope for us. We don't have to do all these manual steps that we have done here. This is my y variable. and this is my x variable, and I wanted the machine to calculate things normally, and I wanted to return additional statistics if it is required. Look at this. The statistics, the line estimate function also returns the slope value, exactly the same value as we have generated it manually. For calculating intercept, there's a function called intercept itself, where we have to just supply our x and y variables. So we see my intercept which we have generated manually is the same thing that was calculated by the machine also. Now we know the formula. What is the formula? Y is equal to minus 1.71818 into x plus 65.109091. Now we know both in slope and intercept. Since we know both slope and intercept, it is all about supplying the x value and predicting a value out of it. Now let's predict what will be the values for the existing data only using the model that we have built. Sorry about that. Um, Y is equal to mx plus c. So in this case, what is my m value? My m value was this. I'm freezing this into my x value. This is experience plus my intercept value. That is also I'm going to freeze. Now in the initial place for 10 years experience, the salary was for 73,000, but the machine says no, don't give 73,000, give 47,000. For 2 years experience, initially my data set had 76,000, but the machine says no, give them only 61,000. For 11 years experience, my machine said only in the original data set we had only 10,000 as salary, but the machine is saying 46,000 as salary. Now let me plot the predicted values with the actual values and see what is the pattern that the machine has created. Look at this. It has calculated a trend line which is following a pattern of straight line. Let me plot this. So it has plotted a straight line through which this pattern will be followed. If someone is going to come up with an additional salary or additional experience, using this pattern only, the salary for them will be calculated. Let me put the trend line here. Delete the line that I created. Look at this. It is showing you the trend line as a straight line. That is the idea of linear regression. Now let me ask the machine to show me what is the MR functions formula for creating this trend line. We created a formula called y is equal to minus 1.718 x plus 65.10 something. Let's see what is the machine is going to give us. It is series 1 trend line. It is linear regression. I wanted the machine to display the equation on the chart. If you see the equation, y is equal to mx plus c is exactly the same value that we have calculated using a manual steps. So y is equal to minus 1.7182 plus into x plus 65.109, which is exactly the same value that we have calculated. Now, if I want, what is the initial purpose? What will be the salary for a person with an experience of 15 years? That is the question. In order to answer this, the salary part, what we will simply do is we will do the same operation with the help of numbers that we have generated. Mx plus c. So this is my m. My x value is 15 plus c. What is my c? My intercept. So the salary for a 15-year experience would be 39,000, $39,000, $39,000, some decimal places and toward. So basically, rather than keeping the process at a random state without any pattern in it. It is always good to create a pattern and generate insights out of it. This is the overall idea behind regression. Let me show you the same thing in Python. Multiple linear regression is simply nothing but when we have multiple independent variables to predict the target variable, then it becomes multiple regression. Whereas in simple regression, we will use one numerical variable to predict one numerical variable. Whereas in multiple regression case, we will have multiple independent variables which are numerics in nature to predict one target variable which will be numerical in nature. Let me show you how does it actually work. I can show you the easiest regression as well. So we can plot simple linear regression as well as multiple regression also. This is multiple linear regression. I'll show you simple linear regression as well. Yeah. In this case, I'm reading the data set where I have price and age. So using price, I can predict age, or using age, I can predict price. Two numerical variables. One will be target, another one will be uh, my independent variable. I'm seeing outliers and then seeing the relationship between these two variables. They are negatively correlated, price and age. So see what I'm doing is I'm taking price as my independent variable and age as my dependent or target variable. Then I'm asking the machine to build a simple linear regression model, which will give us what is the score. Score in the case is accuracy here. Here it is intercept, and then we have slope also generated. Then we can ask the machine to show what is the prediction that it has made for all the price that it is already there in the data set. So if you see the age column, the first values are 57, 57, 58, 60. But what is the model predicting? The model is saying 77, 76 and 75. Then we will see what is accuracy. Basically this is the R square score, which is the relationship between two variables. Initially price and age were distributed like this, but after building the model the data will be distributed something like this. Okay, following a simple straight line method. Whereas talking about multiple linear regression, I have multiple columns. Everything is um, everything is numerical in nature. I'm saying take all the columns as my independent variable and keep only the last column, which is petrol consumption, as my target variable. So I'm going to predict petrol consumption with the help of four different independent variables. I'm building a linear regression model and asking the machine to predict it. It is exactly the same thing like how we did in simple linear regression, just that when we have multiple independent variables, it becomes multiple regression. If we have only one independent variable to predict one target variable, then it becomes uh, simple linear regression. That brings us to the end of this class. Let me quickly recap what we have learned in the class. We started to learn about Pearson's correlation coefficient, which is simply nothing but a relationship metric which will tell you what is the relationship between two numerical variables. What suppose if I have two categorical variables, and what if I wanted to understand the relationship between both of them? In those cases, we will not use Pearson's correlation. We will go with chi-square test. Then talking about regression analysis is all about identifying or evaluating the relationship between two numerical variables. There are two ways in which we can perform regression analysis. One is through simple linear analysis method. Another one is multiple linear regression analysis method. The difference between simple linear and multiple linear regression is simply nothing but it if it takes only one independent variable to predict one target variable, then it becomes simple linear regression. If it takes multiple independent variable to predict only one numerical value, then it becomes multiple linear regression. Both the logics remain the same, just that the input supplied data is slightly different from each other. They, however, form the pattern of creating a straight line for each dimension. That's the idea. You can plot this in Excel, you can plot this in Python, you can plot simple linear regression in Tableau as well. So that brings us to the end of this class. Thank you so much for joining this class. We will connect in the next class. Please don't forget to share, like, share, and subscribe to this channel, OdinSchool. Thanks everyone one more time.